Hello students, in this lecture we will find the transfer function from the Bode plot. Okay, so in previous lecture we have seen how to calculate or how to draw the Bode plot from the given transfer function, but here the magnitude plot is given and you need to find the transfer function. So let's see the procedure. So calculation of transfer function from Bode plot. Procedure. Step 1. Identify the type of the system. As I told you that type of the system will decide or will give you the starting point. Okay. Suppose type 0 system is there. So you know that starting slope it will be always 0 dB per decade. For type 1 there will be one pole at origin. So starting slope it will be minus 20 dB per decade. And for 0 we know that starting slope it will be plus 20 dB per decade. Okay, so from the magnitude plot itself you can find the factors present in the transfer function. So step number 2, finding constant term k. So you know that from constant term k again it will give you or it will help you to find the starting point. Step number 3, find where is the change in slope and what is the change in slope. Where is the change in slope means you will get a corner frequencies. For example, here the magnitude plot is given. You know that magnitude plot is nothing but an asymptotic plot or where the line slope is changing at a corner frequency. Okay, so you can check that here actually the line slope is 0 dB per octave. This is an example taken with octave. Generally we used to take example with decades, but here I have purposely taken with octave. Okay, so you can check that here line slope is changing at a particular frequency. So these frequencies are nothing but a corner frequency. Okay, so in step 3 it is given that find where is the change. Okay, so these are the changes and what is the change in the slope. Okay, so what is change means you need to check the change here. Okay, here there is a change from minus 6 to minus 12. Here there is a change from minus 12 to minus 6, because it will give you an idea about the factors. Okay, step number 4, change in slope it can be calculated by new slope minus old slope. Whereas when we are calculating or we are drawing the Bode plot, that is magnitude plot from the transfer function, in that case the formula it will be old minus new. But here we are going in a reverse way, so it will be new minus old. Okay. Step 4, transfer function will be multiplication of all the factors or all the above determined terms. Okay. So this is about the procedure for calculating transfer function from Bode plot. Now we will see the numerical. Okay. So determine the transfer function of a system whose asymptotic gain plot is shown in figure. Okay. So you can check that here magnitude plot is given. Now you know that y-axis here that will be magnitude in dB, x-axis is actually log omega axis where frequencies are given. You can check that here 0 it will be for y-axis and 1 10 raised to power 3 10 raised to power. Actually this is not 1. Okay, so we will just start with the next frequency 10 raised to power 3. Okay. Now the important thing is that first of all you need to identify the type of the system. Look at this. Here starting slope is 0 dB per octave. Okay. When I am saying octave, so for one pole your slope will be minus 6. For two pole minus 12. For 1 0 slope will be plus 6 dB per octave. For 2 zeros it will be plus 12 dB per octave, like that. Okay, so everything will be same, only here slope is changing. In case of decade we used to take minus 20 minus 40 plus 20 plus 40, but here it will be 0 6 minus 12 or it may be plus 6 plus 12, like that. Okay, now type of the system is actually 0, so there will not be any pole at origin. Now number 2, look at this 20 log k to the base 10. Okay, here we know that here 100 dB is given. So this will be nothing but this shift. I will say this is nothing but a shift. Okay, this shift is 100 dB. From that shift you can calculate 20 log k to the base 10. Okay, so this is actually the reverse process. So from that you will get a value of k. Okay, 20 log k is equal to 100. Just substitute. Okay, and then calculate. So you will get k is equal to 10 raised to power 5. Okay, now next, see here. Actually you know that this is a type 0 system, so no pole at origin. So previous slope is 0 dB. Okay, Now the slope is changing to minus 6 dB. When I am saying minus 6, so you should think about that. When the slope is changing from 0 to minus 6, there must be pole. There must be the finite pole, or there must be the real pole. Okay. So in case of octave scale, we are using minus 6. So there must be the minus 6 as a 0. But see, what will be the corner frequency for that finite pole? This 0 dB per octave is changing at 10 raised to power 3. So what will be that factor? Okay. So how I will calculate? Look at this. Here I will just write like this, the factor. Okay. So this factor, it will be, look at this, how I am writing, 1 plus j omega. Look at the corner frequency, 1 plus j omega by 10 raised to power 3. But this factor, it will be in the denominator. So can I write like this, the factor, it will be 1 upon 1 plus j omega by 10 raised to power 3. Because this is a pole. Okay, so this should be in the denominator. Now my next factor, you can check that from minus 6 to minus 12. Again you need to add one pole there, then your resultant slope, it will be minus 12. Okay, so now my next factor, directly I am writing 1 upon, why I am saying 1 upon, because you can check that here I am getting minus 12. So there must be pole that is added with the previous slope. Okay, so 1 plus j omega by, here you can check that what is corner frequency at which the slope is changing. It is changing at 10 raised to power 4. Okay, so I am writing here 10 raised to power 4. So this will be my next factor. Okay, now you can check that from minus 12 to minus 6. So actually the magnitude is decreasing. Magnitude is decreasing. Okay, so what you will add here so that the resultant is minus 6? Look at this. When I will add plus 6 to minus 12. When I will add plus 6 to minus 12, then only I will get minus 6. Okay, so what factor I will add so that the resultant is minus 6? I will add 0. Okay, I will add 0. That is, I will add plus 6 in this. Okay, so that the resultant is minus 6. Now, my next factor, it will be, look at this. Now it will be in the numerator because I am adding 0. So 1 upon j omega. Here, see the corner frequency is 10 raised to power 5. So this factor I need to add in the numerator. Okay, I hope you are getting. You can conclude that here 3 corner frequencies are there, so there must be 3 factors. But according to the slope, you need to select appropriate factor. Now directly I will write the transfer function. Look at this, transfer function is equal to, my transfer function is equal to, see, constant k I am getting as 10 raised to power 5. Then in numerator I am getting the factor as 1 plus j omega by 10 raised to power 5. Okay. In denominator I have 2 factors, that is 1 plus j omega by 10 raised to power 3 and 1 plus j omega 10 raised to power 4. Okay. So this is my transfer function. You can arrange this transfer function by replacing j omega as s. Okay, so your transfer function will be, transfer function is equal to 10 raised to power 5, 1 plus s by 10 raised to power 5, 1 plus s by 10 raised to power 3, in second bracket 1 plus 10 by s 1 plus s by 10 raised to power 4. Okay, so this will be my transfer function. I hope you are getting. Okay, so this is simple way to calculate the transfer function from the magnitude plot. Thank you, students.